Hi, this talk is a series on shift left. And shift left is everywhere. Everybody has been talking about it, and I thought to do a talk around it and kind of walk you through what the shift left is about. This series is going to be like a five-part series. This is the first part. And the series I've titled the shift left, think forward, building smarter data from the start. And let's see how we can go. For this first part is going to be about the introduction to shift left, telling you why shift left is important and why it's something you should think about for your team and maybe for your personal project as well. Let me talk about a moment every data team knows too well. It's 4:47 p.m. on a Thursday. You are just about to shut your laptop when you get this ping from Slack. And the message is simple: the dashboard is broken. You open the message, something is off, and you go to the dashboard straight off to see what the problem might be, and you quickly notice that the revenue has dropped to zero. This was revenue that was just correct a few hours ago. Now it has dropped to like zero. Maybe active users doubled overnight for no reason. It could be something that is off as well. But whatever it is, it just doesn't make sense from what you're looking at. And now it's your job to figure out why this is. Typically, as a starting point, you're going to start from the logs, pinging the engineer, scrolling through last week's release note. And what you're just trying to do is to reverse engineer to know what has changed upstream. I know this sounds familiar, and one of the problem is that too often we have broken process in how we think about data quality. Anything that has to do with data, we push it towards the end in our design, and this creates lots of problems downstream. This problem could have been somebody just changing something from the source data, changing maybe a schema name, and you kind of have this problem cascade throughout all the layers, and is even more complicated if your organization you've built like a medallion architecture and these changes happen in the bronze and it cascade down to the gold without proper communication, and you just have this problem build up. Another example that can help drive this home is imagine you are building a house. The walls are up. You initially had the architectural diagram like we have here. The windows are installed. The roof has already been on. And someone walks in and says, wait a minute, this house is completed. But did we install the plumbing? And all of a sudden, you go back to your design and you see that the plumbing was not part of it and somebody somehow left out the plumbing. The truth is that's what most data pipeline feels like today. We build the dashboards, we launch the features, we train the models, and only afterwards do we realize that we forgot to do the design part properly. What eventually happens is that the data team have to step in to become the plumbers. But the problem here is that the walls are already painted and people are already living in the house. So you take more time, takes more cost for you to be able to dismantle what has been built to install all of that process. And beyond being a dashboard, now we use data for more complicated processes. Now it could be an AI model, and instead of a few very weird numbers, it's giving confidently wrong answers to customers, to regulators, or your executive team. I know it's annoying, but look at it beyond being annoying. It's dangerous. It's dangerous because people make decisions on this data, and the customers are going to be making life-threatening decisions based on the problem that have happened with somebody changing a schema at the bronze layer. Now, welcome to the modern data. That is what we see within the modern data stack. Also, welcome to the reason behind one of the most important shifts happening right now, and is the shift left. So get it right. It's not a tool. It's not even the buzzword. I know when we started, I told you that it's kind of a buzzword and people talk about it a lot. Most of the articles I've read, everybody is writing something about shift left. But it's a mindset, and it's one that asks a very simple but powerful question. What if we cared more about data quality before things break? And that's why shift left is a wake up call. It's about thinking earlier, designing better, and preventing the chaos before it becomes expensive, embarrassing, or even irreversible for anybody to fix. So let's start from the origin. How did we get to shift left? Where is this coming from? I think it started in software development back in the early 2000s. Engineers, they realized something brutal. They found out that they were catching bugs way too late. A developer could write code, pass it to QA, then someone in testing would find something broken a week or a month later. The result is you have these long feedback loops, last minute panic, and very expensive delays. And to fix this, what they did was to move testing earlier in the process. Typically, you would have testing towards the end. When you are done building everything, you've deployed, you push it. But now they brought the testing earlier in the process, closer to where the code was actually being written. So you write your code, you test it before you now deploy. So this process is known as shifting left on the timeline, and it really worked. It worked, and that was how we got to DevOps. And today we have DevOps. CI/CD became the norm, and modern software development got a whole lot faster, and it became more reliable because you know that the code is being tested before it's being shipped. When you look at the visual I have below, it is from Van der Kruisen, and you see that it explains how the shift happens in terms of when attention to quality happens. In the traditional model, most quality efforts are crammed into the end, right before the release. In the shift left model, quality is prioritized earlier during planning and development. That is when it's easier and cheaper to fix things. I'll be speaking more about the cheaper part later on, but just to know that if you are able to test early, it makes it faster for you in the long run, and it also makes it very cheaper in the long run as well. So the same logic is what was now brought into the data domain. This has worked successfully within software and how they ship, and because nowadays we now try to treat data as a software on its own, and most data processes now are kind of automated. We use infrastructure as code to do most deployment, provisioning, and all we do. It makes sense to also bring in this kind of shift left framework into data and see how to make it better. So what we've been doing all this while is, instead of trying to catch data quality right at the point of entry, when a user submits the form or when a user logs an event, what we've been doing is that we've been trying to catch them at the end. And that is why our dashboards break, our models don't run effectively. It could be in the dashboard, in the model, or worse, in production. And by then, it's not just a bug, it becomes a crisis if you're not able to fix it early enough. And so the data world, they are finally borrowing this page from DevOps. And the logic is a simple logic. And what is the logic? If we want reliable outcomes, we need reliable input. And the earlier you check them, the cheaper they are to fix. Now let's talk about the rule of 10. The rule of 10 is one of the simplest and most brutal principles in systems thinking. And it says that every time you delay fixing a problem, the cost multiplies by 10. I think this concept was popularized by Barry Boehm. He is a pioneer in software engineering. He wrote about this in his 1981 book, Software Engineering Economics. Boehm presented some of this data to show that the cost of fixing a problem keeps multiplying by a factor of 10 the more we delay in fixing the problem. So a classical example, let's say you catch a bad value or a missing value in planning or architecture stage. Maybe it was going to cost like $10 to fix. A quick meeting, a code tweak, a note, or even just meeting somebody over lunch to say, look at this problem, could I just fix that? But if you don't, and you miss that, and you don't catch that until development or systems testing, the cost go up to fix. And let's say it's going to be about $100 or even $1,000 or more. If that issue is not fixed at that stage and makes its way onto the production stage, where it breaks a customer dashboard or corrupts an AI model feeding life decisions, or even something even more critical, that's almost like 100,000 in lost trust, wasted hours, and brand damage. And here's what it looks like. If you look at the diagram that I got from the Code Intelligence to explain this, I can see the architecture design, development testing, system testing, and it keeps going up the more you delay in fixing that. And yes, this absolutely applies to data. So let's say someone on a product team silently changes the name of an event that tracks signups. No one notices what has happened. And days later, your marketing dashboard shows a massive drop in conversions. There's going to be a lot of panic. The data team spends hours trying to trace the issue. Meanwhile, your CEO is in a meeting wondering why customer growth just fell off the cliff. That little field name that was changed It cost the product team 5 seconds to do that. It cost the business days of confusion and thousands in lost productivity. And you can see the image I have here. The end goal is that you start losing money. And that is why businesses try to ensure that quality is at the start of any kind of implementation within any data framework. So shift left has gained popularity because it's not just a best practice, it's a cost control strategy. And it's about fixing things when they are small, quiet, and cheap before they explode downstream. Now, I've mentioned AI a lot, especially when I compared it to having a dashboard and AI model. It could be something even more, a recommender system or any kind of product you build with your data. But let's talk about AI for a while because AI is taking over many things and you have people building agents with the data that they have and all they do with it. One core reason, maybe even a vital one for the shift left, is the AI wave and the fire that AI is catching right now. 5 years ago, if your data was a little off, like if a campaign ID was mistyped or product category got mislabeled, you might have spotted it in a report and you would try to fix it and move on. I know it could be annoying, but it's not really catastrophic in the sense. As we started going data science and now we have AI, that same bad data might be training a machine learning model. And if the model is wrong, the consequences don't show up in a spreadsheet, they show up in automated decisions. Let's say your customer support AI uses historical complaint logs to triage incoming tickets. If these logs are full of miscategorized issues or poorly labeled tags, your guess is as good as mine. Your model will learn bad habits. It might route high priority tickets to the back of the queue or even misclassify billing errors on technical bugs. And you won't notice. That is the point. You won't notice until an angry customer starts tweeting at your CEO or somebody barging to your office, or even one of your teammates notices. And that is why this is even more scary and why shift left has become sort of the foundation for every team. Most data products are no longer dashboards anymore. You just don't know when the revenue falls to zero. They are making recommendations and they are trying to predict, giving suggestions, giving advice, giving decisions, helping with decision making. This is the new reality of AI. It's fast, it's scalable, and it will amplify whatever data you give it, whether it's a good one, whether it's bad. For AI to be ultimately useful, it requires the right data quality as the foundation. To explain this, let's go through what I've called like the trust track. And this is nothing new, but I've just kind of categorized it in these 3 layers to explain what I mean. When building an AI model, and why the AI factor is critical, at the bottom, that is where you'll have the raw data quality. This is the foundation. If your source data is inconsistent, incomplete, or even outdated, nothing built on top of that would hold. Nobody is going to use that for anything. And you come to the second layer, where is the data understanding and context. Before data feeds a model, it needs to be well defined, documented, and understood. What does churn mean in your business? Now you're talking about data mapping, your data dictionary, your metadata. Everything needs to be well accurate and within a defined quality framework. You need to know if your churn if it's based on inactivity, if it's based on cancellations. What does mispayment mean? Models can't reason. You need to be able to help it reason. You need to be able to define this so that if it sees cancellations anywhere, your model knows that this is what this means. And the model can only reflect. It cannot really reason. It can reflect what you fed into it. And it still goes back to the old process of computer usage. It's a garbage in, garbage out. And it is what you've defined that you get out of it. And the last part is where you now have the model behavior or explainability. At the top of the stack is the AI itself. But if something is off at any of these bottom layers, you need to trace it back down through the layers. Can you explain why the model made that decision? Can you prove that the input data was trustworthy? And if this is right or not right? I'm going to wrap up this first part and just to say that the summary of all I've been talking about is that shifting left is about catching data issues early, because late fixes are expensive, risky, and very unreliable. It's a mindset that says, let's stop reacting to broken dashboards and start building processes that prevent them. And it's something that, everyone should be really interested in looking at. In the next part of this series, we'll go much deeper to look at how the role of data team is evolving and why they are not just analysts or engineers anymore. They are becoming system designers, product collaborators, and quality architects. And we're going to be looking at that. So look forward to the next one. And I think I'm going to be seeing the next one. Please, if you find this interesting, why don't you like and subscribe so that others will have access to this? If you're listening on Spotify, you could just give us a follow, drop a comment. And if you're watching on YouTube, that is fantastic. You can also like, subscribe. I'll see you in the next one. Bye for now.